Hello everyone, welcome back to Ma'am Balot's Math Tutorial. Today we will be discussing the mutually exclusive events and the dependent and independent events. What are mutually exclusive events? These are events that cannot occur at the same time, or events that its intersection is empty or a null set. Here is the illustration of a mutually exclusive event. Here we have events A and B which are mutually exclusive. So since they don't have an intersection, then its circle of sets is not overlapping. So if we compute for the probability of A union B, you can have only the probability of A plus the probability of B. Example number 1. A bowl contains 15 chips numbered from 1 to 15. If a chip is drawn randomly from the bowl, what is the probability that it is a 7 or a 15? So observe that a chip of a numbered by 7 and a chip numbered by 15 are different chips. So this is a mutually exclusive events. So to compute for the probability, since it uses the word or, so we will be computing for the union of the probability of getting a 7 and a 15. So following the formula of the probability of the mutually exclusive events, we have now the probability of getting a 7 plus the probability of getting a 15. So in probability of getting a 7, we have 1 over 15 since we have one chip numbered by 7 and then we have 15 chips all in all. Plus, the probability of getting a 15 is also 1 over 15. So we have here 2 over 15. Example 2. In the same situation, what is the probability that it is a 5 or divisible by 4? So we already know that we have only one chip that is numbered by 5, but what are the chips that are divisible by 4? So we have here the numbers 4, 8, and 12. So since they don't have the same chip with the same number, so this is also a mutually exclusive events. So computing for the probability now of 5 union of the numbers divisible by 4, so we have probability of 5 plus the probability of the divisible by 4. So probability of 5 is also 1 over 15 since we have only one chip numbered by 5, plus the probability of the numbers divisible by 4 is 3 over 15. Since we have three numbers there which are divisible by 4, which are 4, 8, and 12. So adding it up, we have 1 plus 3 is equal now to 4 over 15. Now let's have the events which are not mutually exclusive. If you observe in the illustration, we have now the intersection of sets A and B. So this is not a mutually exclusive events. So to compute for its union, so the probability now of A union B is equal to the probability of A plus the probability of B minus the probability of their intersection. So we subtract the intersection because we have counted this part twice because they overlap. So that's why we subtract the other one. So let's have an example. In the same situation that we have earlier, what is the probability that it is an even or divisible by 3? So what are the numbers which are even? We have the numbers 2, 4, 6, 8, 10, 12, and 14. How about the numbers which are divisible by 3? We have 3, 6, 9, 12, and 15. Observe that we have the numbers 6 and 12 which are common to the two sets. So these events now are not mutually exclusive since they have an intersection. So to compute for the probability of even union divisible by 3, we have now the probability of even numbers plus the probability of the numbers divisible by 3 minus the probability of their intersection. So the probability of even numbers is 7 over 15 since there are 7 even numbers plus the probability of the numbers divisible by 3 is 5 over 15 since they are 5 numbers divisible by 3 minus their intersection which is 2 over 15 since we have two numbers which are common on the two sets. So 7 plus 5 minus 2 is equal now to 10 over 15 which can be reduced to 2 over 3 or 2/3. Another example. In the same situation again, what is the probability that it is divisible by 4 or divisible by 3? So the numbers which are divisible by 4 are 4, 8, and 12. And the numbers which is divisible by 3 are 3, 6, 9, 12, and 15. So we have here a common number which is 12. So again, these sets are not mutually exclusive. So applying again our formula, so the probability of divisible by 4 union divisible by 3 is equal to the probability of divisible by 4 plus the probability of divisible by 3 minus their intersection. So the probability of divisible by 4 is 3 over 15 since we have 3 numbers plus the probability divisible by 3 is 5 over 15 minus their intersection is 1 over 15 since we have only one number which is common to both of them. So 3 plus 5 minus 1 is equal now to 7 over 15. Now let's have the independent events. If the occurrence of one of the events gives us no information about whether or not the other event will occur, this is what we call the independent events. Or it just means that if one event does not affect the other, so we have an independent event. So if we get now the probability of A intersection B, so we have probability of A times the probability of B if the events are independent. Example, a box contains 5 red and 7 white marbles. What is the probability of drawing a white marble, then a red marble if it is with replacement? When we say with replacement, it means that we will return the first marble drawn to the box. So this becomes an independent event because the second marble drawn is not affected by the first marble drawn. So computing now for the probability of getting a white, then a red, so we use the probability of W intersection R, which is now equal to the probability of W times the probability of R, or getting a red marble. So the probability of getting a white marble is 7 over 12 since we have 7 white marbles and we have 12 marbles all in all inside the box. Then multiplied by the probability of getting a red marble, which is 5 over 12 since we have 5 red marbles. Then we have again 12 marbles in the box since we returned the first marble drawn. So multiplying now the fraction, we have 7 times 5 is equal to 35, then 12 times 12 is equal to 144. So we have 35 over 144. Another example. In the same box, what is the probability of drawing both white marbles if it is drawn one at a time and with replacement? So since it is also with replacement, so again, this is an independent event. So computing now for getting white and then white, so we have the probability of W intersection of W, which is now equal to the probability of W times the probability of W. So the probability of getting a white is 7 over 12 times the same probability, which is also 7 over 12, which is now equal to 7 times 7 is 49. Then 12 times 12 is 144. So we have 49 over 144. Now let's have the dependent events. This happen when the outcome of one event affects the outcome of another event. So if it is a dependent events, when we compute now the intersection of A and B of its probability, so it is now equal to the probability of A times the probability of B following A. So this probability of B following A is just represents the probability of B given that A already happened. So let's have an example. For the same situation in the box, what is the probability of drawing a white marble, then a red marble if it is without replacement? So when we say without replacement, it means that we will not return the first marble drawn in the box. So this is now a dependent event, since the second marble that will be drawn would be affected by the first marble drawn. So if we compute now the probability of getting a white, then a red is equal now to the probability of getting a white marble times the probability of getting a red following the white marble. So the probability of getting a white is 7 over 12, since we have 7 white marbles and we have 12 marbles in the box all in all. Then times the probability of R following W is 5 over 11, since we have 5 red marbles and we have already 11 left marbles in the box since we did not return the first marble drawn. So multiplying now, we have 7 times 5 is 35 over 12 times 11, which is 132. So we have 35 over 132. Next example. In the same box, what is the probability of drawing both white marbles if it is drawn one at a time and without replacement? Since we have without replacement, so this is a dependent event. So using our formula, we have the probability of getting a white intersection white is equal now to probability of getting a white times the probability of getting a white following white. So the probability of getting a white here is 7 over 12, since we have 7 white marbles and we have 12 marbles in the box all in all, times the probability of getting a white following a white is now equal to 6 over 11, since we have already 6 whites remaining because we already assumed that the one white marble is drawn in the first draw, and then we have only 11 marbles left in the box since it is without replacement. So multiplying the fractions, we have now 7 times 6 is equal to 42 divided by 12 times 11 is 132, which is reduced further by 7 over 22. So the probability of getting both white marbles is 7 over 22. Now it's your turn to answer your activity sheets. I hope you learned something from our discussion today. But don't forget to like and subscribe. Thank you so much for listening. At your service, Ma'am Balot.